Statistics mean a branch of mathematics used to summarize, analyze, and interpret the group of number or observations. This subject is about the practice or science of collecting and analyzing numerical data in large quantity, especially for the purpose of inference proportions in a world from those in representative sample. The secondary data was obtained from the Department Statistik Malaysia. The dataset was collected through a database on population by age group, sex, and ethnic group in Malaysia. This data aimed to gain insight on the number of population in Malaysia. Based on data, the total number of population for 3 years is 19186,700. The key reason for selecting this data is to gain insight on population by sex, age group, year, citizen category, and ethnic in Malaysia. The population for 3 years show improvement. This report will provide the data description, graphical representation, numerical descriptive measure, statistical analysis using software, and theoretical modeling based on data population by sex, age group, year, citizen category, and ethnic in Malaysia. The variable of interest is the population, which can be viewed from the perspective of different pie. Otherwise, the variable for the pie has been changed so that SPSS tool can analyze the data from the Department Statistik Malaysia.
Assalamualaikum. My name is Nur Haifa binti Abdul Shakur. My matric number is A1980738. So today I will go through with my part, which is graphical representations. From the graph, we can see that the population percentage of male is higher than female, which is 51.65% for male and 48.35% for female. From the bar graph that show the higher percentage of age group is within 50 until 29, that is as much 29.02%. For the lowest of age group is within 75 until 89, which is 2.10%. From the pie chart, we can see that the percentage of Malaysia population is larger than the percentage of non-Malaysia population, which is 89.88% for Malaysia and 10.12% for non-Malaysia. Next, there are 4 types of ethnic such as Bumiputra, Chinese, Indians, and others. The percentage of Bumiputra is 62.10%, Chinese is 20.67%, Indians is 6.21%, and for others is 0.91%. Overall, we can see that the ethnic of Bumiputra is more than others ethnic.
Hi to my beloved lecturer, Mr. Tan, and all my fellow friends. Let me introduce myself. My name is Nur Nadila binti Mak Salimi, matric number A19A0496. So I was asked to present about my part, that is numerical descriptive measures. For this part, I will show and tell all of you about how I describe the data set using various numerical descriptive measures. These include the measures of central tendency, the measures of position, and the measures of variation. So, for the first slide, I start with central tendency. Okay, central tendency can be defined as a single value that attempts to describe a set of data by identifying the central position within that set of data. Okay, first is mean, or often called the average, is most likely the measure of central tendency that you are most familiar with. But there are others such as the median and the mode. Okay, here the formula of mean, median and mode. You have to use this formula to get a value of what I mentioned just now, which is mean, median and mode. So from my calculation using the formula that I show in the slide, the mean value of each group for years 2000 to 2019 based on the population was 31.05216. For the median, we have about 50% of the population in Malaysia. Based on age group, is that 28.0C893, and for the mode is that the highest capacity of population based on age group, and for the year 2017 to 2019 is 21.17013. Okay, next, the measure of position. Measure of position give a range where certain percentage of data fall. And the measure we consider here are percentiles and quotiles. The 25th percentile typically donated quota 1 and the 75th percentile typically donated as quota 3. Quota 1 is commonly called the lower quotile and quota 3 is commonly called the upper quotile. This slide shows the formula for each step to calculate the measure of position. And after calculate the first quota and third quotile, we have to calculate the interquartile range. So here, answer of the quotile range that I got from my calculation. Okay, for the last term is the measures of variation. It is used to describe the distribution of the data, and we considered to use variance measures and its square root and counterpart, which is standard deviation. This is the formula of variance. Then take a value of variance to square root to get in standard deviation. For the shape of data distribution, we have mean higher than median and the median higher than mode. And this show the shape is skewed to the right. Okay, that's all from me. Thank you.
Hi, Assalamualaikum. My name is Munira binti Ubakar. My metric number is A9A0388. Today I'm going to present about statistic analysis using software SPSS. Numerical descriptive measure of central tendency. As you can see from the table, we use manual and SPSS, mean, median, mode. Mean for manual we got 21.05216. For SPSS we got 34.058. Median for manual we got 28.06893. For SPSS we got 10.950. Mode for manual we got 21.17013, and for SPSS we got 0.8. This mean, median and mode show the different result between SPSS because this SPSS cannot read the data accurately. Measure of variation. Simple variance for manual we got 390.41899. For SPSS we got 1360.778. Standard deviation for manual we got 19.75902. For SPSS we got 36.8887. The result SPSS for data sample variance and standard deviation is not the same as manual because of the SPSS cannot read the data accurately. Measure of position for quarter 1, quarter 3 and range. Manual for quarter 1 we got 15.146462, and for SPSS we got 3.250. Quarter 3 for manual we got 44.36189, and for SPSS we got 64.800. Range for manual we got 29.215424, and for SPSS we got 104 0.6. Standard deviation and variance show different results because of the error of the system SPSS to analyze data separately, which is the data of the age group too large for 3 years. 4.2 Hypothesis testing, one sample test. There are various categories under a field such as sex, age group, year, citizen category, ethnic, and population. The DF of all the categories remain unchanged at 509. The test for the sex is 67.683, while the main difference is 1.500, and the confidence interval of the different lower is 1.46 and for upper is 1.45. For age group, the t-test is 46.045, and while the mean difference is at 3.353 and the confidence interval of different lower is 3.25 and for upper is 3.50. Next, for the year categories, the t-test is 45.263 while the mean difference is 2.000 and the confidence interval of the different for lower is 1.93 and the upper is 1.93. For citizen category, the t-test is 47.859 while the mean difference is 1.022. And the confidence interval of the difference for lower is 1.17 and for upper is 1.23. The ethnic t-test is 47.859. The mean difference is 3.000 and the confidence interval of the difference for lower is 2.8 and for upper is 3.12. Lastly, for population, the t-test is 16.452 and the mean difference is 190.1700 and the confidence interval of the difference for lower is 167 and 460 and for upper is 212.880. ANOVA. The explanation of the ANOVA is the p-value from the ANOVA table is less than 0.001, which means that at least one of the three variables for sex, group, year, citizen category, and the ethnic. Correlation. The value of R between sex and the population is negative 0.024 and the value in age group and population is negative 0.333. The value R between year and population is 0.005. The value R between the citizen categories and population is negative 0.180. And the last one, the value R between ethnic and the population is negative 0.638. This shows negative correlation between population, sex, age group, citizen categories, ethnic, while positive correlation between population and year. This shows that there is strong direct correlation between population and years. Confidence interval. We use 95% of degree of the confidence. For age group 0 until 15, the difference between lower boundary and upper boundary is 148.146. For age group 15 until 29, the difference between lower and upper boundary is 139.212. For age group 30 until 44, the difference between lower boundary and upper boundary is 104.93. For age group 45 until 59, the difference between lower and upper boundary is 72.581. The age group 60 until 74, the difference between lower and upper boundary is 41.117. And the last one is age group 75 and the age group 75 until 89, the difference between lower boundary and upper boundary is 90.059.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Fatihah Najwa binti Mak Khalil, metric number A19A0734. I will continue my part, theoretical modeling. First, the graph. The graph shows association between a population by 5 variable. First, sex, second, age group, year, citizen category, and ethnic. There is a high-level association between the population and sex, population and age group, and population and year. There is no clear association between population and citizen category and ethnic. Next, a correlation. Population correlation highly with age group, citizen category, and ethnic. There is no significant correlated between sex and year. Among the independent variable, the correlation between citizen category and ethnic is very high. Most likely, there is a problem of multicollinearity. Next, model summary. The R-square value is 0.665, which means 66.5% of the variation in population can be explained by ethnic, year, age group, sex, and citizen category. The adjusted R-square is 66.2%. The Durbin-Watson statistic is 2.102, almost 2. Next, ANOVA. The p-value from the ANOVA table is less than 0.001, which means that at least one of the two variables, ethnic, year, age group, sex, and citizen category, can be used to model population. Thus, for every unit increase in sex, population will drop by 12.560, provided the other variable remain unchanged. Besides, based on the standardized beta coefficients, the effect of age group, a negative 0.333, is almost 3 times of sex, negative 0.024.
To sum up our presentation, I would like to tell all of you that several methods were used to calculate the data that we choose, which is data arrangement, graphical representation, measure of central tendency, measure of variation, and for the last, measure of position. All the methods help us to calculate each part to finish our report about population by age, group, sex, and ethnic group in Malaysia from 2017 to 2019. Thank you.